It's a pleasure for me to be with you during this session. We're going to see some kind of different perspective of the definition of DDMRP and clear proof of why this is not a good thing to do. Only a good thing to do is almost a must for all companies that deal with inventory. So the agenda we're going to cover today is somehow different definition of what is DDMRP. We're going to talk about the current practices that we see in everyday businesses today. They are non-systemic, they are non-suited for the current reality, and the results that they are producing are absolutely suboptimal. So that's a key point. And then we're going to talk about a very important key thing about DDMRP, which is the fact that this methodology is called a descriptive model. We're going to see what it is, and the issue that DDMRP is solving, the key problem that any supply chain in the world is facing. So that's one of the reasons why we can claim that DDMRP could be applied to any company in any sector, any size, that is dealing and planning inventories in any place of the supply chain. That's the agenda we'll try to cover. I usually spend about 3 hours doing this presentation. I'm going to try to compact it in the available time that we have. Let's see how it goes. Okay. What is DDMRP? We claim that this is the knowledge frontier clearly in material planning execution. And the definition that we give is that this is a systems-based model for planning and execution of materials along the entire supply chain, pull type, descriptive, and disruptive. And I'm going to try to explain all of these words because all of them are important. Let's start with systems-based. Thinking systemic, holistic is kind of a sexy word that we here in management today, we are thinking systemically, we are thinking holistic. And when you ask people, what do you mean by that? What is a system or what is system thinking? You usually hear a very profound silence in the audience. And let's explain that with let's say a very basic example. Let's suppose that we have hired the best 10 automotive engineers in the world, and we tell them that we have a warehouse where we have all these cars that you are seeing there, the best cars in the world, and we ask them, go there and bring us, let's go and see and test all the motors of those cars and bring us the best motor. They go there, they make their test and analyze every motor and bring us, let's say, a Rolls-Royce motor. Okay? Say thank you, and then we ask them, why don't you bring us the best transmission? They go there, analyze them, and they bring us the transmission of a Mercedes-Benz. And so on with all the parts and components of a car. And we end up, let's say, with a warehouse where we have an image like this, but in this image, you are seeing all the components for building this car in a specific. But we have a much better circumstance. We have the best parts in the world of each class, okay? And we tell these engineers, the reason why we ask you to bring all these parts is because we want to have the best car in the world. So you have the parts in there. Please build the best car in the world. Those guys are going to tell us it's not possible, the parts don't fit. This is mainly an example of how companies are being managed all over the world right now. We want to have the best general manager, the best financial manager, the best marketing manager, the best, but the parts don't fit. And that's a real problem that we see all over the world. I think you understand what I'm talking about. And the main reason why we have to move to systemic thinking is very basic. We define a system like anything that has components, relationships, and a common goal. For sure, any company goes into that definition. And if we are dealing with a company that is a system, then it should be managed using systems thinking. If you want to fix a machine, you bring a mechanical engineer. If you want to talk about chemical things, you bring a chemical engineer. If you are talking about a system, you have to bring a tool that is called systems thinking, which is very uncommon to see, not very much taught in universities, but it's one of the key foundations of DDMRP and all the demand-driven models. And again, it's a body of knowledge with very specific proposals that if you have not heard about that, I suggest that you take a look. There is plenty of information in the internet. Okay. And there are many key things about complex systems. Just one example. In complex system, cause and effects are separated in time and in space. Let's say this cartoon. This guy, in a minute, when he got this big block in his head, you are going to come here and try to ask who did it and why did he did it. This is a very, very interesting representation of what is one of the behaviors of complex systems. And again, just one of many of them where cause and effects are separated in time and space. Many times they are not very intuitive. And again, if you have not heard about that or not familiar with this body of knowledge, I strongly recommend that you take a look at that. So let's say do some very brief things about systemic thinking. We can spend hours in here, but just some brief comments. When you're thinking systemically, it is far more important to manage the interactions of the parts than the actions of the part. This is not very common. What we do when we are running a company is that we are seeing and supervising the actions of the parts. I mean, what the people are doing, what are the tasks, what are the activities, are they doing it well or not? But here we can see that it's far more important to manage the interaction. How what I'm doing is influencing the rest of the system, how it's affecting the other parts of the system. If the system is taken apart, both the whole and the parts lose their essential properties. Very important. If you take let's say a car, the components of a car apart, let's say you take a wheel by itself doesn't work. And then if you take the wheels out, you don't have a car, right? So in order to get a system working, we have to have something very, very difficult to obtain, which is synchronization. In a simple definition, we have to synchronize the operation of the company. We have to make the parts work together and avoid the very common practice of these big silos, everything working on their own and having suboptimal results. So this is the explanation of why it's based in system thinking. We are trying to synchronize the supply chain. We are trying to think systemically and trying to avoid the very common practice of working in silos. This is a model for planning execution of materials. Planning. I think I have asked more than 1,000 people from the United States down to Argentina and Chile, what is planning? People working in supply chain planning. Give me the right definition of planning. Not a single one of them has come with the proper definition. I'm going to give it briefly. Planning is creating a desirable future, making decisions in advance. Again, creating a desirable future, making decisions in advance. Let's say I want to plan the vacation with my family. The desirable future is to have a good rest, good time. Almost all of us like that. So we have to make decisions in advance. When are we going on vacation? How much money do we have for the vacation? With that money, where can we go? If we decide to go to a city, to which hotel? Which excursions are we going to take? And so forth, we have to start making decisions in advance in order to create a plan. Okay? How does this definition apply to supply chain? What is the desirable future? Those are the widely accepted KPIs in supply chain, which is number one, maximum service level. Number two, maximum market response speed. Number three, minimum inventory. And four, minimum aggregate expenses. So in that order, we want to have maximum service level, maximum speed, with the minimum inventory and with the minimum expenses. Most people know that this is what they want to get. But if you know what you want and you have a good way of achieving that, we're just talking about a wish. So this is the desirable future that we want to create in supply chain planning. And which kind of decisions do we have to make in advance? What to buy, when to buy, how much to buy, when, how much, and what to produce, what, how much, and when to distribute if you have entire supply chain. And there is a big difference in doing it well or doing it wrong. This guy in the top is the owner of Zara or Inditex in Spain. You may know that guy. It's called Amancio Ortega. And he is doing everything that is not the usual common practice. It's not intuitive. It's not what most people are doing. And he is by far the more successful guy in the world right now in his industry. He's growing and growing and growing. And at the same time, this is just an example. This is a slide from a long time ago. This is just an example, as I mentioned. Many of the retail chains in the world are going through a very difficult times. They are doing exactly what is told to do. And this guy is doing exactly the contrary. And he's, again, having a lot of success. And most of the companies in the clothing and retail business are going through very difficult times. All of them has Amazon in front of them, but still Zara is growing and growing and growing. Okay, and one of the key reasons why Zara is successful is widely known. Is they claim and they say it everywhere is due to the way they plan and they execute the supply chain, which again is totally different to what most people are doing. So doing it well and doing it wrong makes a huge difference for any company. Okay, that's planning. Now let's say execution. Let's come to execution. We cannot talk only about planning. Companies has planning areas. There's a planning manager or whole team of planning. Nobody's talking about execution. And we have learned during all this time we've been implementing the DDMRP since 2013 that companies have a huge problem in execution. You can see here, this is a report from I think it's the Economic Business Intelligence Unit that says that 95% of business strategies fail to due to poor execution. It's not enough with good planning. We have to go and make a good execution. And again, the constant is a constant that most companies, maybe all companies we've been working with for the past 8 years, they have huge problems in execution. When we start planning well, you see a lot of execution problems emerging. Nobody was talking about those problems, but now they can identify them and start trying to get in solutions for those problems. So again, execution is as important as planning. And one of the most key important things that we see right now is the problem with the execution. A lot to improve in that area. That's planning and execution of materials. Any supply chain can be explained by two entities. That's stocks and flow, any supply chain. So here you have, let's say, an entire supply chain from suppliers to a retail point. And you have the flows in here, you have the inbound logistics, the production, scheduling, and execution, and the outbound logistics. So it's stocks and flows. DDMRP, again, is about the stocks, the inventories, and it seems like a very simple concept, but our experience shows that many people get confused with that. They don't really distinguish or make a clear difference between materials planning and, let's say, production schedule and execution. So maybe most of you know that DDMRP is about how to plan and execute those buffers along the entire supply chain. It's a pool type. Most of you know the concept. We can talk about that for a long time. We don't have the time today, but it's a, let's say, a basic concept. Most of you know we are not based in forecasts. We are just replenishing on the real demand. And the two concepts that I want to include in here is that this is descriptive and disruptive. Descriptive, this is a very important thing. There are two professors from MIT. Maybe some of you know this book, one of the most important books in operations ever written by Hopp and Spearman from MIT in 1996. They define factory physics as a systematic description of the underlying behavior of manufacturing system. What is the point in here? Hopp and Spearman, they say that there are two types of models or kind of solutions for any problem that you have. One could be based on descriptive models, and there are other based in what they are called the prescriptive models. What is a prescriptive model? Let's start with that one. A prescriptive model is that, let's say you go to the doctor sees that you have headache, you have congestions in your nose, your throat is, you have pain in your throat. So the doctor says, you have a cold, take this pill. So it means you see some circumstances, and according to different circumstances that you have seen before, you identify a similar one and you give a solution, okay? This is like a recipe. If you have this problem, do this, okay? A descriptive model, on the contrary, goes down to the underlying behavior of the system and understands the basic rules which governs the system. And that's what they mean in the definition that they give about factory physics. They claim in that book, it's a 500 book, not easy to read, but if you don't know it, take a look at it. It's one of the most important things ever written, as I mentioned. So what they're saying is that in this book, they present what is the descriptive fundamental problem that you face in operations. It's not a recipe. We are full of recipes in operations. If you have a problem with big MOQs, go and do a SMED project. If you have a problem of waste, go and do a Six Sigma project, and so forth. Here they say we have a fundamental problem that we have to solve, and it's the same problem that any supply chain is facing. So they present that model. I'm going to talk about that a little bit later, very briefly, but is one of the most important things is that when I learned about DDMRP in a video by Chad Smith in 2012, is because I read factory physics back in 2001 or 2, and I learned that it was based, DDMRP is based under the same descriptive model that factory physics presents. And Hopp and Spearman clearly demonstrates that with mathematical reasoning and physics reasoning, without a doubt, that there is a single common problem to any supply chain that should be solved. We're going to see that shortly, okay? And disruptive. Why is this such a disruptive methodology? This is one of my heroes. He's a not very well-known person. He's a well-known person within the system thinking community. She was called Donella Meadows, died some years ago. And she wrote a very important paper in 1997, I think, that was called Leverage Points, Places to Intervene a System. You may take a look at that on the internet, it's there. And in that paper, Mrs. Meadows proposed what she calls the leverage points in a system. That means, which are those factors in a system that you can operate on that are going to bring you the most benefits in the system. And you can see there from the most important to the less important. So the first one is the power to shift paradigms. Second one, the paradigm used. Then the system goal, the system structure, system rules, and down to constant parameters and numbers. You can see that most of the improvement projects in the world are based in here. Constant parameters and numbers. Reduce waste, increase the output of something. But here you have a list of all the really important leverage points. And the reason why DDMRP is so disruptive is because it uses all of them. All of these leverage points are used by DDMRP. I wrote an appendix on one of the Carols and Chat book on that. You can take a look at that. It's in the Precisely Wrong book by Carol and Chad, and maybe you can get a better explanation of that. When you're using everything here, starting from the paradigms, you get a really disruptive methodology. DDMRP uses them all. Okay. When people ask us what is DDMRP, we tell them before getting to a clear definition of what it is, we have to understand the problem that we are solving. If we don't have a problem, we don't need a solution. And we have to define the problem correctly in order to provide the right solution. Okay? What is the real problem here? A very important thing. Right now, what the current practices all over the world that most everybody is using are based on things that were developed in the last century in the United States in a non-globalized world. During that time, demand was growing faster than supply, especially after the Second World War in the United States. So companies did not have enough capacity to supply everything that the market was asking for. So it was a seller's marketplace. Virtually everything that was produced was sold. So companies were working at full capacity. And under those circumstances, when you are selling everything that you produce, which is a different condition to what we see here in the world today, under those circumstances, inventory is always an asset. It is assumed that anything that is produced or purchased will be sold soon. Maximizing production output is always good. Forecast error is irrelevant, and many other conditions. When you are working under those conditions, it is very, very right to say that the only way to make money is to reduce cost. So if you reduce cost, you're going to make more money because you're selling everything that you're producing. And the paradigm that is right for those environments is this: minimizing unit cost is the main way to maximize ROI. And this is still the same paradigm that we see today. I think you're familiar with reduce cost, reduce cost, reduce cost, be more efficient, be more efficient, be more efficient. This is still the paradigm that we're using, and it's a totally wrong thing and wrong approach because this is the right rule for different circumstances. When you sell everything that you produce. Now the world has changed a lot. We all know that. We see all that everywhere. It is a buyer's market. Supply is larger than demand. Not everything that is produced is sold. We have this thing of the VUCA that we have seen all over the place. We have long lead times, forecast error is on the rise, etc., etc., etc. And we cannot use the same paradigm if the circumstances have changed. Okay, so if we are using the wrong tool, we don't get very good results. This is what we get all over the world today. Service levels are not good, inventory turns are not good, we have long lead time to markets, urgencies on planning and frequent changes in production schedule, tensions between purchasing and production, tensions between production and sales, finance always wondering how to improve, with no real solution at site, clients canceling orders, promotions, blah, 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 blah. These are absolutely suboptimal results. And is the natural outcome of using the wrong tool for these circumstances. We are working with the right rule for different circumstances. If you are selling everything that you produce, it's fine to focus on reducing cost. If you are not selling everything that you produce, which is the common circumstances, using the same rule is absolutely wrong. So under these circumstances, we have to move, we have to change to a different paradigm. So the way or the right way to define this, to what to change, is from a perspective focused in reducing cost to a perspective focused in maximizing flow. Andrew Carnegie said in the 20s, he said, keep a real close look at the cost and profits will come. That was true because at that time, any ton of steel that went out or came out from a steel mill in the United States was sold. So they were working at full capacity, and that was right. Now it's changed. So if you are not selling everything and you are working on these new circumstances, you have to move to flow. In a short sentence, DDMRP proposes that we have to move from focusing in reducing cost to living in reducing time. You can have the lowest possible cost in your industry and it still get broken. Why that would happen? Because you are producing very, very cheap, but you are not selling what you produce. So in this environment, we have to move from reducing cost to reducing time and chasing real demand. And the new paradigm is this one, which is George Clause's law. Most of you have seen it. That says that all benefits in the ROI are directly related to the speed of flow of relevant materials and information. Relevant was added by Carol and Chad, you may know that. Some examples. Benny Shipper, 1575. This is true. In 1575, the Venice shipyard took 1 day to assemble a ship when they had all the parts available. They invented the assembly line, they invented standard, they invented the way how to manage an assembly line with a specialized work and blah, blah, blah. It's a very interesting stories in the internet. You can take a look at that. 1913 Ford. It took Ford 72 hours to convert material that is in a iron mine and convert that into a finished car. Very interesting story. Toyota. Taichung always said our main concern and goal in Toyota was to reduce the time, not the cost, the time that it spends, that happens between the moment that we receive an order until the moment that we receive the money. They were focused in time. Sara is not based in cost. All the literature in Sara says that they are more interested in and focused in having a very good response time to market. Is their main goal, response to market, not cost. There are many things that shows that in Sara. Okay, what do we expect when we move to time? We expect the right KPIs that we mentioned: maximum service level, availability, minimum lead time to market, minimum inventory, minimum expenses, all at the same time. This is what we get when we do a good implementation, when we focus in time, and it has been proved over and over and over all over the world. Okay, and what is, besides the problem, the descriptive model that we mentioned that it was presented by Hopp and Spearman in Factory Physics. Very shortly, in any supply chain, say this is an extended supply chain, but it could be a short one, some parts of it, or whatever you consider you have in your company. There are lots and lots of suppliers, lots of machines, lots of people, lots of distribution centers, retail points, lots of customers. Every single factor here is has variation and has variability. Everything is moving in the supply chain, okay? Suppliers, they have variability in their deliveries. Machines, they have variability. People have variabilities. And the market has a lot of variability. We don't know what they're going to buy, how much they're going to buy. So there is a lot of variability in every single point of the supply chain all over the place. Here, what we see right now is that the way that companies are managing their systems is in the silos, sourcing, production, and distribution. So sourcing is taking care of this part, production is taking care of this part, and distribution is taking care of this part. And they work in silos. So again, we have to go back to the systemic thinking. We have to see that this is a single supply chain where materials and information are flowing, and with a lot of variability all over the place. There is something called the variability law, and the descriptive model that Hopp and Spearman presented in Factory Physics says the following. What you want to do is to improve flow, same as DDMRP. And the real problem that companies face when they try to improve the flow is called the variability propagation. It's not the fact that you have variability. Everything has variability. But there is this law called the variability law that says that the longer the system, the more the variability is going to propagate, and you have two very adverse consequences of that. Number one, productivity or output is going to decrease exponentially. And number two, lead times are going to grow exponentially. And this is what every single supply chain in the world is facing. Again, the proposal is do not focus on cost, move to flow models, but take into account that the most important or the main obstacle to flow is called the variability propagation. That is going to have these two consequences: decrease in output and decrease in lead time. This is clearly shown in Factory Physics. This is the same proposal of DDMRP, so that's why DDMRP is also a descriptive model. And when you have a descriptive model, good thing is that there is only one single possible solution to that problem of the variability propagation. That again happens in any supply chain. There is only one possible solution. And the only possible solution to synchronize demand and supply in the presence of variability is by including buffers. This is why we deal with buffers in the DDMRP. Buffers is not just an inventory position. It's a decoupling point. It's stopping the variability that is passing along the system. So it's going to help increasing output, decreasing lead time, and also is going to be serving as a planning position. And a buffer, the good definition of a buffer is an excess resource that corrects misalignments in demand and supply. This is the definition given by Factory Physics, is also what we accept in DDMRP. And there are only three kinds of buffers. You have stock buffers, time buffers, and capacity buffers. In DDMRP, we deal with stock buffers, and in finite scheduling, which is the let's say the brother of DDMRP, and that is part of the demand-driven operating model, finite scheduling, we use the time and capacity buffers. Okay, so this is a basic definition, very important, is that The main obstacle to flow is the propagation of variability. There is only one solution to that problem, is including buffers that are going to stop that propagation. And there are only three kind of buffers: stock, time, and capacity. DDMRP is stock buffers. Finite schedule is about time and capacity buffers. And in a simple slide, DDMRP works in a very, let's say, simplified way. Let's say that you have a complete supply chain and you have a retail point in here that are replenished from this regional distribution center. And let's say that today, this retail point sold 5 units of one SKU. This sold 3 of the same SKU, 2 and 6. Very simple. Tomorrow, or as frequent as possible, we are going to replenish 5, 3, 2, and 6. And these guys are going to be used 16 units, which is the sum of that, replenishing this retail point. So they are going to ask for 16 units to the finished product warehouse. And in this regional distribution center, we use 14. So 14 plus 16 is 30. So the finished products guys are going to say to the plant, replenish 30 units. There are MOQs, there are rules, but that's the basic logic. And when you replenish these 30 units, you're going to be using some raw materials, and you're going to tell your suppliers, please replenish these raw materials. Again, there are MOQs, rules, very basic, very simple. But this is in a, let's say, one slide, the way how the system works. So what we do is that we are going to, define where to put all these buffers. It's not anywhere, everywhere. There are rules for defining where to position these buffers. It's the first component of DDMRP, strategic positioning. Then we define how big are we going to size these buffers. We adjust them dynamically. Then we replenish them, and we do the execution, which is a key part of the model. So there are 5 components to do DDMRP: where to place them, how big to make them, how to adjust them, how to replenish them, and how to do the execution. These are the technical aspects. This is details that very simple that you can learn in 2 days in a demand-driven planner class. So in short, this is what DDMRP is in a very short time that we have available today. This is what DDMRP is, a different definition. Again, it's a systemic model. Let's remember what planning is. Execution is very important, and that is descriptive and disruptive, and that we are solving the most important problem, which is the variability propagation, that there is only one solution to that problem, which is including buffer, placing buffers. There are only 3 types of buffers: stock, time, and capacity. And DDMRP is about stock buffers, and we have these 5 components in the methodology. Sorry for the rush. We have very short time, so I'm open to hear some questions at this point.
So the first one was, how does DDMRP address the fact that past usage does not equal what our customers would have bought had we been able to deliver?
Very nice question. Thank you very much for it. There's a different terminology that I use for that. The third component of DDMRP is the dynamic adjustments. Every company in the world is the combination of 2 kind of events: pull events and push events. Pull is whatever you are replenishing, and this is the normal consumption, and the historic demand is going to take care of that, and that works very nice and finely. Push events are those that in which you have to, let's say, pre-build an inventory for something that is not going to be, or it's not going to respond to historic demand. Let's say new products, you don't have history for that. A promotion, a seasonality. Those push events, they have to use what in DDMRP is called a planned adjustment factor. So that's, let's say, change in the buffer in advance in order to take care of the push events. Okay, so it's within the methodology. The third component would take a little bit more to, let's say, explain in detail, but it's within the methodology. You can use what's called the future daily usage. You can have planning adjustment factor, and so forth. So there is a way of doing that within DDMRP.
Let me just kind of go through these. So the next one is, where should the buffer be allocated?
No. That was the first question that I asked Chad in 2012, and I said, how do you, let's say, how do you define the position of the buffer? And he said, as a long reply, why don't you come and take the DDP with me? And so I did. So there are several factors to position the buffers. Depends on the time to market, the customer, the time, the customer tolerance time, the critical operations, the variability on demand and supply, blah, blah, blah. So that's a technical thing that would take a little bit more than the available time today.
Great. Someone asked if the PowerPoint will be available. We will be sharing recordings from the sessions. It looks like this is the last question. What makes DDMRP logic different than theory of constraints logic replenishment, or are they the same?
Well, before going into DDMRP, I used to work in theory of constraints. Actually, we did a lot of projects in theory of constraints. DDMRP has a lot of the logic that the theory of constraint uses, but what I think is that DDMRP is a more advanced methodology than theory of constraints, because Goldratt, he was a genius, but he died very young, as you know. It was 10 years ago when he died. And in my opinion, he didn't have the time to develop the operational things that DDMRP included. Let's say in the three zones of the TOC buffers, you don't have an MOQ. You have variability factors in the way that DDMRP is taken care of. So there are many things that makes DDMRP more, let's say, logic, or it allows the implementation easier, but it's based on the same principles, or one of the main principles that Goldratt developed, but it's based on TOC. Okay.
Terrific.